All right, so we have subsetted our data to just the values that we want to work with. We might also need to create some new variables in order to analyze them, which is a very common thing we might have to do. The way we can do that in dplyr is with the mutate function. What mutate does is it assigns columns or variables, so you can create variables with it. There's a sibling function called transmute that does the same thing, but then drops anything you didn't just create. We don't typically use that, but it is there. So with mutate, which is, if you're familiar with pandas, very much like assign, you can assign multiple variables in the same mutate. You can separate them by commas. So you just work sort of like you'd expect. I say, hey, I want to create a variable called next year. So I'm going to take this year and add 1 to it. I'm making a new variable. And here's my name of the new variable. I'm setting it equal to the combination of old variables that I want to use to create the new one. It will automatically know that I want to go row by row and do the calculation on each row. So 2014 plus 1 becomes 2015, and so on. Here I'm creating a logical variable. I'm checking whether income is above 100,000. Maybe I want to check whether this logical condition is working as I expect it to before I use it for a filter or something like that. And so I'm creating another variable called above 100K, which is equal to income being above $100,000, which is false for Ramesh and true for both Whitney and David. I can create multiple variables at the same time with one mutate command by simply separating them by commas. And that's basically it for mutate. That's how you create a new variable. The difficult part is thinking of how do you do that, right? What is the actual combination of variables that you want to use to create it? But once you know that, the mutate part is pretty easy, right? So take year, add 1 to it. That's my new variable. Here's the name of my new variable. Done. One handy thing that you might run into when you are creating variables with mutate is case when. Case when is a dplyr function that's very nice when you are creating categorical variables. So let's say that I want to create a variable that's like, I've got your years of education and I want to bin those into didn't graduate high school graduate, some college degree. Maybe I want to make those different categories. Case when is a good way of doing that. So you provide case when with a series of if-then statements, and then it goes through your data one by one and just checks whether each statement applies to that row. And if it does, it assigns a value. As soon as it finds one, by the way, it stops looking. So you can assume that anything that satisfies a condition up here is not going to need and not going to be fall into a condition down there. So here's an example of how that looks. So here I'm making an income bracket variable using the person and year data. Creating this new variable equal to a case when function. Inside of the case when function, I've got a bunch of if-then statements. If your income is below 50,000, then you get the label under 50,000. If your income is above 50,000 or below 100,000, then you get 50 to 100,000. If your income is above $100,000 but below 120,000, then you get 100 to 120K. And then I can just say true. This is the catch-all for everybody else. And if you still haven't been caught by any of these, then you are above $120,000. You can see how this plays out, right? This income is 50 to 100,000, so it gets this label down here. These ones are above 120K, so they get above 120K. These ones are between 100 and 120. It gets that label over here. Notice, as I mentioned, it checks each one as it goes down. So if you are below 50,000, then it catches you. So actually, this part is actually not necessary because if you get to this point, we already know that you're above 50,000. That's why also, by the way, the true works here, because if you are, let's say, below 50,000, you're going to stop here. You're not going to keep going until you find one that's true for you. So anybody who's still left at this point gets the true. And so that's just the catch-all for everybody who's left over. So case when's really handy for binning variables like this, for recategorizing variables like this. You could even do something like, let's say you had a data set that was state names as abbreviation. So CA, you could do if state name equals CA, then give me that California as a whole, right? You could do something like that. One other thing about case when, you can also use case when. You don't have to do it for categorization. You can use it for recalculating stuff. So let's say, for example, you had data on different years of income, like we do here, 2014, 2015. And maybe I want to adjust for inflation. I can do something like, hey, if the year is 2014, then multiply income by 1.02 or whatever to account for inflation, right? To adjust for the CPI. All right, next up is group by in terms of creating variables. So group by turns the data set into a grouped data set. What this does is it gives you you can give it a set of keys, and any calculation you ask for afterwards, it will do that calculation separately for each group, each combination of the grouping variables. If you follow up a group by with a mutate or a summarize, it will process the data separately. So like here's an example. So I'm taking this person in your data, I'm going to group it by person. And now when I do a mutate, if I do some sort of summary calculation on the data, it will do that separately for each person. So I'm doing the income minus the mean of income to see how much income you earned this year relative to your average, your person-based average. So here's Ramesh, and income relative to mean is negative 420 in 2014 and positive 420 in 2015, right? Ramesh earned $420 more than the average in 2015 and earned $420 less than the average in 2014. And this is separate for each individual person, right? It's calculating the mean just for Ramesh. When I calculate the mean of income here, it's not everybody's mean income. It's specifically Ramesh's mean income. And we can see that that's working because it's exactly the same above and below, because these are both relative to the same Ramesh mean. Same thing for Whitney. Whitney gets her own income in the average income in the 2 years, and then the same above or below, and same thing for David, right? This is super duper handy. If you want to create some sort of calculation by group, which is a very common thing to want to do, then you want to group by first. So a couple things about group by. So first of all, it will maintain the grouping structure until you ungroup it or regroup it or do a summarize, which I'll talk about in a second. So how is this useful? How is group by helpful? So remember, our goal is to look at where information is and think about where we want it to go to. Group by is a very good way of making sure that if we want to do some sort of adjustment, but only want to do it separately for each individual group, then it allows us to do that. So we can do stuff like calculate averages by group. Or I mentioned before, you can use lag to look at one row above to see how things have changed since yesterday. But what if I want to make sure that you're only comparing to yourself yesterday and not to somebody else yesterday? Well, I can use group by to make sure that I'm only looking at yourself. So group by it helps move information from one row to another in a key variable. I want to calculate the average across all the different rows within a particular group. That's one way I can do things. I can also use group by with summarize, which I'll talk about next, to change the observation level. I'll get to that in a second. Some additional tips when we're using group by is that there are some special functions that give us information about the groups that we have. So n, for example, will tell you the number of rows in the group, which can be handy. If you want to just count up how many observations there are by group, then n will allow you to do that. Or row number will show the row number within the group of that observation. So for example, let's go back to our person year data here, or let's say our joined data. Look at that. So let's say that I want to calculate, let's say, let's do the average budget for each group. So let's do joined data. Let's group by, let's do the monthly averages. Let's do that. Group by month name. And then I'll do mutate month average is mean of budget. Look at that. We can see that on the average budget in January was 5, in February was 4.5, and so on. Then I could do stuff like see what your department's budget is relative to that monthly average. So maybe I'll do relative to average, a new variable in my mutate, month average, just your budget, divided by the month average. So I can see relative to the month average, I can see that sales spent 20% more, R&D spent 20% less, and so on. I mentioned using n and row number. Let's see what we can do with that. So let's say I'm going to calculate that mean budget, but for some reason I want to do it by hand. Now obviously in this case we have a mean function that does it for us, but I could also do something like this. I could say sum the budget and then divide by the number of observations in each group, which will give me the exact same values, because that's what a mean is. You sum things up and you divide by how many there are. Now, in this case, there's no real reason to do this, but you can imagine some other instances in which I might want to actually count things up. Maybe I'm doing something that's more complex than a mean and doesn't have a canned function for it. So I mentioned summarize a couple times. Let's talk about summarize. So summarize is another way of creating variables that changes the observation level to a broader level. Basically, you do a group by, and then you do a summarize, and what you should have at the end is one row per group. So if I group by person and then do a summarize, I will get back just one row for David, one row for Ramesh, and one row for Whitney, because those are the individual groups that I had. So I do this by telling it how to summarize each of the variables that I want. So I want to get mean income, I take the mean of income. I want to get years tracked, I give it the number of rows. And this tells me how many rows I have for each person and also what their average income is over the entire thing. This also changes the observation level. I used to have one row per person per year, and now, since I grouped by person and did a summarize, I only have one row per person. Now, group by and summarize is fantastic. It is a solution to default to a lot of the time. Let's say I want to make a graph about the average budget each month. Well, I can do that really easy. Joined data, group by month name, summarize, month average equals mean budget. Right now I have the average, budget in each month on average, right? Easy, and I can graph this if I want to in a very easy way. There's a lot of times when the solution to a difficult problem is simply to do a group by and summarize, especially in data visualization. If you're having a hard time doing something, you're banging your head against a wall, unable to get something to work, ask yourself, hey, can I solve this with a group by and summarize? The answer is often yes. Another thing to keep in mind with summarize is that you do need to give it calculations to tell it how to summarize the different variables. So here, notice if I wanted the average of budget, I told it to take the mean of budget. If I don't do that, if I just say budget, it won't do it properly. It'll just give me back the original data that I started with because it doesn't know how to take all these different budget observations and collapse them into one observation per group. I need to tell it how to do that. Take the mean or take the median or something, right? So it doesn't work if I don't do that. Lastly, neat little tip here. If we're talking about a binary variable that we're summarizing, you can get the proportion of that binary variable by just taking the mean of it. So let's say that I want to get the proportion of observations in each month for which the budget is above 6, let's say. So I can do joined data, group by month name, and summarize proportion above 6, and that'll be the mean of the budget being above 6. So this is a binary indicator. This will be a true, false. It'll be a logical. Is the budget above 6 or not? Let's maybe make it above 5. And then it will take the mean of that. It'll give me the proportion of observations for which the budget is above 5, which is there aren't any in April. There's half of them in February, half of them in January, and none of them in March. All right, lastly, and this is really more for aesthetic purposes than for anything else when we're talking about creating variables, there's rename. Rename simply renames your variables, which can be very handy if you read in a data set and it's got some weird variable names, or just in general, if you're doing data communication, you want to make sure that people know what your variable names mean. So naming them something intuitive makes a lot of sense. It can be nice for making names manageable, making them show up nicely in visualization. So, don't skip it. It's not hard to do. Rename your variable is something that people will actually want to read and understand. So rename works pretty simply. I take my data, pipe it to rename, whatever I want the new name to be, what the old name was. So I'm going to take this person variable and rename it to name. I'm going to take this income variable and rename it to annual income. Notice, by the way, the backticks here. These are the same backticks that we used in our markdown. What they're doing here is they're allowing me to have an improper variable name. So in R, variable names can't have spaces in them. They can't have certain characters in them, like percentage signs or stuff like that. But you can still do it as long as you wrap it in these backticks. This basically allows anything goes inside of that variable name, more or less, with a couple of exceptions. So I can have a variable name with a space in it, which is very nice for the readers of my table who don't want to see annual income. They want to see annual income on their table. And I can do that with these backticks very easily. All right, so those are some ways in which we can create variables in our data sets using dplyr. We can use mutate to literally create new columns of data. We can use group by to make those columns while doing calculations within groups. I can use case when to create categorical variables by treating the data differently depending on different conditions. I can use summarize to take a group's data set and flatten it down to just one observation per group. And finally, I can rename variables into something nicer to read using the rename function.